since a lot of people apparently like my tutorials. I have no idea why any of you like my tutorials. I'm chaotic. But oh well, I'll record it for those who think that I'm entertaining. Just verifying you guys can see my screen. I want to know before I go into this. I got a thumbs up. I don't know if that was to the chaotic or you can see my screen. I'm
Yeah, we
hoping
can
it
see your
was to
screen.
the. All right. Well, under the assumption that everyone can see me, let's just start rambling about what a class is, eh? So, welcome to object-oriented programming, ladies and gentlemen. This week was not actually supposed to be object-oriented programming. However, A7 and A8 were released, which means that you guys will need object-oriented programming. You don't actually need file-based programming until A9, I believe. So we're not gonna. Well, no, I think we removed all of the files from A8. So next week we're doing files, and then the final week, I don't even know what we're doing. So ha! I haven't looked that far ahead. So what is a class? Because a class is the core of object-oriented programming. And I wrote up my little blurb here so you guys you could just download the notebook and not need me. But a class is very much a function, but for data, not instructions. That's really all it is. If you have a function performing a series of operations on data, a class is a way of organizing that data that you want to perform operations on. And the closest way I can describe it that you guys would understand is through dictionaries. So I've coded up a little example that is closer to what you guys are typically used to seeing in this course. It's a dictionary where the keys are some sort of properties of a human being, and the values are, well, just that. They're values. These are the values that I want to operate on. So every human being will have a full name, an occupation, an age, a hair color, and an eye color. This is for simplicity. I'm not being rigorous, but it's what you basically need. And I've created a function which accepts a person dictionary, and it should only accept a person dictionary, but I'm not doing any type checking. And it performs a power level calculation, which is it's pretty basic. It's just a whole bunch of lengths, and I have a dictionary here because I can. And what I want to do is I want to turn this into object oriented because I know both Mark and Dick share the same, or both Mark and Nick, apologies. No, both Mark and Nick share the exact same data in the exact same way. And this function does the exact same thing on both. I want to make a person class, a class that actually allows me to organize this data. So that way, all I have to do is this. And I'm going to take you step by step translating the dictionary into the class, putting the function in the class, and instantiating the class. This is the big thing that you guys need to understand for the assignment 8. After we cover that, I'm going to explain real quickly what object inheritance is, and then we open the floor up to Q&A. This is going to be nice and quick, hopefully. So I'm going to take the original Mark dictionary, so that way we can actually compare what a human being dictionary is compared to a person class. So if we look at the left side, we have keys. These keys need to be passed into the function. So first I'm going to tell my class how it's going to build itself. And in order to do that, we're going to use something called init. Init is a built-in Python function that basically says, start making a person. So we know that we have a class person. I want to make the person using the init function. And notice how it has 2 underscores on both sides, the left and the right. The 2 underscores means that it is built into Python. It is something that you are replacing in Python source code. Another example of something that's built in that you guys need for assignment 8 is underscore underscore add. What underscore underscore add does is it allows you to actually take some sort of person object and use the plus sign with another person object. This defines addition. You guys will be able to do more of that, though, on the assignment. We're not covering that in tutorial. So, killing add, because we just want to look at a init. We want to build a human being, a person. First and always, you guys need to get this in your mind. You pass self into every function in the person. You can imagine self as being the dictionary. If I want to have self at full name, I write self dot full name. It's a variable in the dictionary. So if self is the dictionary of data, self will contain a full name, an occupation, an age, a hair color, and an eye color. So let's go ahead and copy these into place. So I'm saying my self dictionary will have a key called full name, a key called occupation, a key called age, a key called hair color, and a key called eye color. However, I need to pass in these variables. I need to tell it that the full name is Mark. I need to tell it that the occupation is software developer. I need to give it those variables. So in my function, I'm now going to add the appropriate variables, what I want to give to the dictionary. I want to give it a full name, and that's just a variable. I could call it whatever I want. I want to give it my occupation. I'm going to call it job. I'm going to give it my age. I'm going to give it my hair color, and I'm going to give it my eye color. So these variables would be the values. So let's throw them in the dictionary. Self.full name equals the full name. Self.occupation equals our job. Oops. Self.age, it equals our age. Self.hair color, well, that's equal to the hair variable. And self.eye color is equal to the eye variable. So now, when I create a person, I could take this information, Mark Hutchison, software developer, 20 years old, brown, and brown, because I have both brown eyes and brown hair. So now my person class can be instantiated with all of these variables, and it will automatically build the dictionary. I want to make sure that everyone gets this general flow before I move on. So if anyone's got questions, interrupt me now, and we can cover them. Otherwise, hold your peace.
I'm a little bit confused as to how it knows which value is what. Like, how does it know that your name is self.full name?
So init is a function, right? So the order of operations very much does matter. So when I define person goes into the class and says, all right, he's defining a new person. We're going to init. We're making a dictionary. And then everything else, if you look, Mark Hutchison is the first parameter. It's the first parameter. Software developer is the second parameter. Job is the second parameter. Age is the third. Age is the third. Brown for hair. Each of the variables perfectly matches a parameter in the function. And then I take those variables and I'm putting them in the dictionary using these keys. So I could call this name, and it's also perfectly valid because what really matters is self.full name. That's me saying, okay, the full name key in the dictionary, that is going to be, name, the variable. Does that make a bit more sense?
I think so. When you're going from the dictionary to create, like, does this just create a new dictionary? Like, create the dictionary you had initially?
Essentially. So Mark, this line of code and where is it? Because I have my clipboard. This line of code and this line of code are doing very much the exact same thing. However, this is doing it using a class. This is doing it using the dictionary.
Got it. Thank you.
All right. Anybody else got something for me before I move on? Because I gotta show you. Now that we have this, I gotta make a function for it. This is not going to be fun.
What's the self? Can you just explain the self part? Like under init, you put self dot full name. What does that do?
It's literally the exact same as saying if you had a dictionary called self, dot full name goes, okay, full name, name.
Yeah.
Python automatically translates self into a dictionary, and then these dots are the same as saying a key in the dictionary.
Okay. Okay. That makes sense. Thank you.
All right, so I'm gonna paste the original power level function and this power level function, and we're gonna basically take this, translate it into the class, because there's a bit of tweaking we have to do. First things first, first rule, always pass in self. Every function in the class needs that self dictionary. It always has to be the first thing it gets, so that way it knows, like, I want the Mark dictionary, or I want the Nick dictionary. I want whatever dictionary you want manipulated, it has to be passed in. Now, you can see here how I do mark.powerlevel. This is the exact same as saying person.powerlevel mark. If you think about it, I'm asking the class to perform power level on the Mark dictionary. So Python has two ways of writing this. You can either write self.powerlevel, in which case self doesn't get passed in as a parameter, or you call the person class and you give it the dictionary. Both of these are valid. You guys will definitely probably want to use the self.powerlevel notation. That's a little confusing, but at the end of the day, just remember, although you pass self in as a parameter in the class, you don't have to do it outside of the class. See how I'm not providing the mark variable in this init function? It makes no sense because the variable's already out here. It will automatically get put in as a parameter, and it will automatically become self. It's a lot to wrap your head around. We can come back to it later. At the end of the day, just remember, although you put self in as a parameter, you never actually put self in the function calls. There is no self to put here. It's all automatic. It's a bit wonky. It's one of those things where I can't understand why Python did it that way. I can only tell you that that's how Python did it, and we have to accept it. So self is always the first, and then whatever my person is right there. So let's go line by line. First line is this level function. However, the person isn't a dictionary anymore. We're assuming that it's a class. So instead of person.fullname, or sorry, person key full name, we actually have to do person.fullname. However, that's passing a person in. If you think about it, mark.powerlevel, my person is Mark. I don't actually have to pass in a person because self is my person. So does it make sense to pass in a person? No, not really. So if I remove person, how do I get Mark's full name? Well, I just ask self to give me the full name. So my person is self. Very, very much the same thing here. If I have person at occupation, instead, let's do self dot occupation, because I want whatever my person's occupation is. Then we have the following if statement. Again, it's very similar. We have person.age, or person at age, sorry. should be self.age. And I can copy that into all occurrences of person at age because we're replacing all of them. Variables in object-oriented programming are the exact same as normal. If I want to make a value called color values, I just define it however I want. You don't have to make a class or any special notation. Everything's the exact same. It's just every time I see person, I'm replacing it with the self notation. So for color in person.haircolor should be self.haircolor. And for eye color, it should be self.eyecolor. And then I can delete this. And this is basically the exact same line of code, but now translated for my self dictionary. If I wanted to pass in a different person, so if I wanted to find out like what the difference between Nick and Mark's power level is, I could do that, and it's not that hard. But this was what I had previously. Power level person, power level self. So let's take a look at an example where I do pass in two different items, where I have both Mark and Nick. So I'm going to make something called diff power level. I want to know what the difference between Nick and Mark's power level is. Let's assume that. So we have self and we have some sort of other person. And what I want to do is I want to take self's power level, self.power level, and I want to subtract other's power level of other.power level. And I want to find out what is the numerical difference between these two values, because both self and other should have a power level. So if we do print Nick dot diff power level, and remember, since Nick is self, I only have to pass in one value, whatever other is. And I'm going to pass in Mark as my other. I can run this cell. Person has no attribute diff power level. Did I make a spelling mistake? Is there a capital P somewhere? There is a capital P. Self has a lowercase function called power level, not an uppercase function. So Mark's power level is only 62. Nick's power level is legendary. It's 147, which means he is 85 power points above me. Before I move on, I know you guys definitely have questions. Come on, guys. This is a bit harder to understand, so I would be surprised if you didn't have questions.
After you put in the color values dictionary, you say for color in self, so that little block of code, what are you doing there?
Okay, so this is me going through. So see how Nick has blonde and brown as his hair color? What I want to do is I want to take each of those colors. I want to take blonde and brown and add the value of both. So what I'm doing is for every color in person's hair color, I'm going to take the value associated with that color and I'm going to add it to their power level. So Nick's brown hair is worth 5 points and his blonde hair is worth 8 points. So together they make 13 points. That was the goal of this loop.
Got it. Thank you.
This was just me trying to come up with a more interesting function than just add age, add length of string, add length of string, add length of string, etc., etc. I was trying to be funky. All right, I'm not seeing a lot of questions, so I'm assuming then you guys would be able to define a function and define a init function and be able to do the basics of an object. And that's really all you need for assignment 8. You need to know how to work with the self dictionary, and you need to know how to make functions, either a custom function or a built-in function. So remember, there's add, there is what else? There's mul, there's rmul. If we ever ask you to override a built-in function, we're gonna give you what the function name should be. So if we want you to override equality, we'll tell you it's at EQ. If we want you to override print, we'll tell you it's at string. Stuff like that. So you will never be given a question and not be told what the function names should be called to get them to work.
Sorry, can we for the different types of, like, for init, like, what does that do in particular, like, relative to, like, the other ones?
So init is a builder. It literally just makes the self dictionary. If you were to look at __ add, that overwrites Python's plus operation. This plus, whenever I do 5 plus 7 in Python, I'm actually saying the int class pass in the number 5 dot __ add __ the int class of the value 7. This is what Python does every time you write a 5 plus 7 command. It rewrites it to this because that's how Python looks at everything. It's really weird. When I do 5 equals 7, it's very much the same thing. __ EQ __. And even when you think about it,
to writing it that way, like to writing it as add or as EQ?
No. It's just completely how you choose to do it.
Okay.
It's just, this is how Python translates everything you pass it. So if I were to do the most verbose thing, 5 equals 7 is a one-to-one translation of this garbage. int.init, the value 5, .eq, and then pass in another int.init, the value 7. It is the most garbage syntax I have ever seen, but that's what Python wants. It's a special little snowflake.
So, like, when we talk about overwriting a function, is that what we're doing?
Yeah, so you would be replacing. Yeah, you would be replacing. So if I overwrote what EQ did, I could make this statement return true. Now, 5 doesn't equal 7. We know it doesn't equal 7, but we have control over that.
Okay, got you.
It's very funky. So very similar, when I say mark.powerlevel, what's a good way? Mark.powerlevel, that's very much a one-to-one translation of the person class .init mark, because that's the variable name, then call power level on the result of that. It's very much a one-to-one translation. If I pass in A, B, C, D, E like that, or actually I should do mark equals person A, B, C, D, E dot power level. This is very much the exact same as saying mark.init a person.init, the mark variable, the ABCDE parameters, and then call power level on that. I don't like how it looks like this because it doesn't make much sense. This makes more sense to me. A mark variable is a person with variables A, B, C, D, and E, and then call power level on that. But this is equally as valid to write. If you were on an assignment and you wrote this, you would lose no marks. It's really your preference. And I show you both, but you're only ever going to be taught mark.power_level, nick.power_level, mark equals person, stuff like that. You're never going to actually like see a nit. You're never going to actually see someone legitimately use add like this. When we ask you to code add, you're very much only going to see people do mark plus nick, not neok. Isn't Python lovely? I don't know how it's. I do not know how Python is considered an introductory language when it is this complex under the hood. When you actually pop it open and see how it works, it's disgusting. But, oh well, the school wanted Python. Okay. Let's move on to less functions and all that. Let's take a look at object types. If I have a cat and I have a lion, should a lion be a cat? This is a question that we actually posed in a midterm once before. So if I just define the classes cat and lion, and I run this, you can see, is Garfield a cat? True. Is Garfield a lion? False. Is Simba a cat? False. Is Simba a lion? True. What happens if Simba should be a cat? How do we get something of the lion class to also be something of the cat class? We have to use something called inheritance. Inside a class, you can pass in another class. So I'm saying lion is a class. However, it's also a cat. Anything that cat can do, lion can do as well. Now when I rerun this, you can see Simba is both a cat and a lion. Garfield, however, does not enter lionhood. The advantage of this is you can make abstract classes and specify only for certain things. So someone give me something that a cat can do, but a lion can't.
Get stuck in a tree.
Sure. You know what? So let's make a function called get stuck in a tree. Oh, wait, no. Lion inherits cat. So, sorry, the lion will be able to do it if the cat can do it. What's something a lion can do that a cat can't do? I want to go one way, not the other.
Can they eat a zebra?
Sure, the cat can't eat a zebra. So I'm just going to quickly make an example. Self.sound equals meow. This is for later. So we're going to say that a lion makes the sound of roar, just for an example I'm going to use. Self.sound equals roar. And yeah, we're going to say a lion can eat a zebra. Eat zebra. It passes in self, and we're going to return yummy. What's something else that both a cat and a lion can do? What's something both of them share in common?
They can walk.
They can walk. I'll take it. Walk. Pass in self, and we'll print the string walking. I'm not going to return anything. I'm just going to print. What's something else only a lion can do?
Guess hunt. Like
we'll say eat zebra covers hunting.
Oh, right.
This is really hard.
Seems like intimidation. I don't know.
I feel like eating a zebra would be pretty intimidating naturally. But you know what we can do? We can do self.intimidating equals true, but in a cat, self.intimidating equals false. I can work with this. So let's say I have Garfield and Simba come up here. So that way I don't have any of that is Garfield a cat stuff. So if I call Garfield dot make sound, because Garfield is a cat, what should print? We look at make sound, it prints self.sound. Self.sound is meow, so we assume it will print meow. There's meow. What does Simba say if I say Simba.make sound?
Roar.
Roar. So if I run this, there's roar. Both lion and cat have this make sound. Because lion inherits a cat, it also inherits make sound. But I've replaced the lion sound with roar instead of meow. If I do Garfield.walk, can Garfield walk? Yes or no? Take your votes. I hope that there's only one clear correct answer. I've got a thumbs up, so. Yeah, walking. Of course Garfield can walk. He's a cat. Can Simba walk? Want to see if I get another thumbs up or a thumbs down? I got a thumbs up as well. Of course Simba can walk. They both have walking. Although lion doesn't explicitly say walk, cat does, and lion inherits cat. Okay, let's take a look. Oh, go ahead.
So for the make sound function, or you have meow under cat, and then lion inherits cat, but whatever's in lion sort of takes precedence. Is that the story?
Yeah, so self.sound has become roar. That is overriding what cat's meow was.
But then, Garfield, oh wait.
Garfield is a cat. Garfield meows.
Right.
But lion is also a cat, but a lion should roar. It shouldn't meow. So I want to override self.sound.
Okay, yeah, that does make sense. I have another question. So in this case, you've said that like lion inherits cat. Suppose if I were to also say that cat inherits lion, would I like break Python?
You would. Python would actually legitimately cry. It will scream at you saying you have an infinite inheritance. Python does not like that. So if we look at anyways, back to the example, Garfield and Simba both have an intimidating variable. However, one is false, one is true. I need to introduce you guys to another thing, however. I need to introduce you to something called super. Super is whatever my parent class is. If you think of lion as a subclass of cat, because it inherits from cat, super is referring to cat itself. It is my super parents, my god class, however you want to think about it. Super allows you to call a cat's version of literally anything. So I could call super.init pass in self, and if I run this, nothing will change. Init takes in one argument. What happened? I guess actually it just does this. Yeah. So if I call super.init, notice how nothing changes. But if I call super.init here, after I've redefined self.sound and self.intimidating, now they match. What I've done here is I've defined self.sound and said it was roar. I've defined self.intimidating, said it was true. But then I said, okay, cat, now call your initialization function. Whatever I've done, is worthless because I have called cat's init function. Cat overwrote sound and overwrote intimidating. So now, because I've done this here, although Simba is still a lion, he's a lion with all of the properties of a cat. So if I run this, I still get Simba as a cat and a lion, though both of those are true. However, if I look at the self dictionary, it is now matching a cat's dictionary and no longer a lion's dictionary. Super is extremely helpful and also extremely dangerous. It depends on how you use it. For example, if I say I pass in a custom sound and I say cat should make the sound meow, but my lion makes the sound roar, right? I could do super.init and pass in whatever sound my lion got. I could pass that into the cat. The value of doing this, if I just print self.sound on both, is they both, Garfield still has meow, Simba has roar. However, I haven't wrote self.sound equals because cat already does self.sound equals. I'm reusing the code up here by saying, yo, super, can you handle this for me? If I also passed in the intimidate as a variable like this, and I pass in false and true, actually, let's not pass in true for intimidate. If you think about it, a lion's always going to be intimidating. So I could just pass in true like this to super. Super takes in a sound and intimidate, but lion doesn't have to take in intimidate. I could just manually say true, and it will still work because it is the intimidating equivalent. When I asked the cat to make or use this init function, it's passed in these arguments. You can kind of think of it like saying self equals cat sound true. This is very much what I'm doing when I say super.init sound true. I'm basically saying self is a cat with sound true.
I have a quick question.
Yeah.
What you know how you defined class lion brackets cat? What if you didn't put cats there and you added super? Would that do anything?
Yeah, if I didn't put cat, object.init takes exactly one argument, an instance to instantialize. If you think of it, super of a parentless class is itself. So if I do super.init, but I don't pass in cat, the super is now lion. It is its own parent. However, this is really sketchy because now Python doesn't want you to pass in anything, and it's crying and it's complaining because super.init is too vague. You haven't passed anything in specifically, so it's always going to fail to run this code. It's really weird. Python shouldn't allow super if there is no cat. But Python allows super if there is no cat. The issue is you can't do anything with it. Does that make sense?
Yeah.
I think I didn't fully understand that. If there's no cat there, like what is super like in reference to?
So by default, all classes do have a superclass called object. It is a generic object-oriented class. It's the parent Python class. So super references object by default. When we manually say cat, we're saying, okay, you're no longer going to be referencing object as your parent. I want you to reference cat as your parent, and cat by default is referencing object as its parent. Now, The issue with Python's object class is by default, it has nothing in it. Hence why it's so useless to refer to it. Like, that's why Python lets you do class cat without specifying object. There's no point. Object is fundamentally useless.
When I'm using super to reference, so I could use super to reference like pretty much anything that is defined.
Yep.
Okay.
But I can't pass in if I don't have a mark class, there's nothing to inherit. It attempts to pass in the mark class. Name mark is not defined. There is no class with that name. I could have lions though be a person. I defined a person earlier. However, I would have to then match the person.init, right? So if you think about it, a person has a full name. We'll call it lion. They have an occupation, hunter. He has an age. We'll call him 4 years old. He has a hair color, orangish. I don't know if that's what you would refer to a lion's hair color. And we'll give him green eyes because he's cool. Now, I have no intimidating. Whoops. However, that's not the important part. If I have an init function and I make a lion variable, and I print lion dot full name because he's a person now, I get the person's attribute. If I print lion dot occupation, because he is inherited from a person, he has the occupation of hunter. If I do power level, a lion has a power level because he is a person. Does that make sense? Oops, it's a function.
Yeah, so in this case, you referred to like your super function is like called the power level function, correct?
Yep. So if I wanted to, if I want to call by default in lion, if I want to then do super dot power level, I can do that. I can say super dot power level, and it will take my lion and it will ask for the power level of it. Now, of course, this won't run, however, because orange is not a color in my dictionary, I would have to add, I guess orange and ginger are similar enough. I'll give them a point. So now if I rerun this, whoops, where's the code? Apparently my lion only has a power level of 37. This is the great thing about super, but also a horrible thing about super.
I'm still kind of confused how you got to power level, because power level is not in cat. Oh,
It's
sorry,
not,
never
but
mind.
I replaced cat.
Yeah,
I
okay,
replaced
sorry, I didn't
person.
notice that.
But if I go back and I change this to cat, it's now an issue because I've passed in so many variables when cat only takes 2. It takes a sound and an intimidation factor. So I'd have to do meow and true. This is still going to error though, because cats don't have a power level function. I could call make sound. That's perfectly valid. But I can't call power level. Whoops. Lion has no power level. Whoops. I'm still doing it. Let's run this. Boom. Prints meow instantly because I've called super.makeSound in this constructor. Anybody else?
Okay, I just want to ask one thing. Is it possible to like, have more than one parent for class? Like, let's say I put class cat comma person.
Something like this?
Yeah.
This is possible, but now super's no longer possible. You cannot do super if you have multiple inheritance. You must now say person.init or cat.init, person.powerlevel, or
Oh.
cat.powerlevel.
Okay.
There's no
Okay, that makes
longer, yeah, there's no longer a clear parent. There's no longer a clear super, so this will fail.
okay. Okay, that makes sense.
Does the order of the inheritance matter?
I don't think so. The
Like
order
if
of
the two have like contradicting values?
the two have contradicting, then yes, it does. So if both cat and person had make sound, it would be in order. So this is why super can't work. Because if you called super.make sound, how do you know which make sound do you want? If you call cat.make sound, it will specifically get cats. If you called person.make sound, it would specifically get persons. The order, they won't overwrite each other because neither one of them is going to be considered the parent. This is why you can't use super when you have cat and person.
So super doesn't default to like the first argument.
No. It defaults to the one argument.
Okay.
If I only have cat, super is cat.
Okay, that makes sense.
Sorry, I have a question.
Yeah, hit me.
So okay, you know how you put cat. Now, if you put person, then you have to take the super out and put cat in it, right? Only on the first line, not on the second, by make sound. Okay, so you do have to change both.
You have to change both. You can't just
Okay.
have one.
Okay, so I just want to clarify that. Thank you.
No problem. Now, why is this not working? And it is missing one required argument, intimidate. Ah, fun fact. This is why I hate super. Super allows you to not pass in self. This is one thing I always forget to do. When you specify cat.init, you must pass in the lion's self object. I always forget about this, and Python always complains because super automatically passes in self on your behalf. So the lion, when I specify cat, I need to tell cat what dictionary to update. That's a big one. I always forget that one. And it's a good thing that I tried testing that, because that's if you guys ever do use multiple inheritance for any reason, I'm not sure why you would do it, but if you ever do, just remember you have to pass in self if you don't use super. So I'm gonna define a make sound in person as well, so you can see the difference between the two. Return hello. Run that so it restarts. So if I call cat.make sound, I should now be able to call person.make sound. And oh, what happened? Return hello. I wanted to print hello, not return. I would have to add in my own manual print statement. So now I have both access to cats make sound and persons make sound, but I shouldn't have access to super.make sound. Or apparently you do. Interesting. Well, William, it turns out your hypothesis of super being the first is correct. I did not know this. Fun fact, guys, you will never deal with multiple inheritance in this course. Why? Because it's a buggy piece of garbage. In a test, if we ever ask you to do inheritance, though, you will never have both cat and person. You would only have cat. Interesting. I just learned something new as a Python developer, and I've been doing this for years. Goes to show you how powerful convention can be.
So out of the two syntax, would you recommend super or cat or cat dot?
Odd. out of the two syntax, I always find myself using super. The only reason I find myself using super is because I hate passing in self when I can avoid it. Because when you're getting variables inside a class, you would use self.fullname. And if I wanted to call a function, I could call self.eatZebra. This calls this. So the way I see it, if I'm saying self.get this or self.do this, I find it more consistent to use super because super doesn't pass in self. But this is my personal preference. If you guys prefer this, then go ahead and do it, because there is also an equivalent. If I do lion dot so if I do lion dot eat zebra self, this is perfectly equivalent to this. These are the same statement. So same as these are the same statement. However, because this only has one version, if I'm getting the self.fullname variable or the self.sound variable, or if anything from my dictionary, if I go into my dictionary and get a variable, this is the only way to do it. There is no lion.sound self. This doesn't exist. So because this is the only way to get a variable from my dictionary, I then choose to use this syntax where it's super.makeSound, self.sound, self.eatZebra. I find it more consistent, but that is the style of the programmer. It comes down to Nick's most hated answer now that I think about it. There is no right answer. Nick absolutely hates that in a programming language. I also absolutely hate that. The way I see it is there should only ever be one correct way to do something. The standards make the programming language faster, and typically, once you learn it, you are going to be much more effective in learning it. By having different ways to do stuff like this, you make it more confusing for the people attempting to learn it. Anyways, that is the end of my tutorial. I am officially out of time, so you guys are free. It's a little sad I didn't get to cover my my project I made. I was gonna go over that if we had time, but I don't see us having enough time for that. So go ahead, be free, ladies and gentlemen. If you have more